Hey, welcome. Have you ever looked at the incredibly complex apps we use every single day and wondered, how in the world do they even build these things? Well, it's not magic. It's actually a blueprint, a set of foundational principles that helps developers turn total chaos into clean, powerful software. And today, we're going to explore that exact blueprint, the 4 pillars of code.
Okay, seriously, think about it for a second. An app like a flight booking site or your favorite social media platform, there are literally millions of lines of code working together. So how do developers keep all that straight without everything just falling apart? How do they add cool new features without having to tear down the whole system and start from scratch?
To really wrap our heads around these big ideas, we're going to make them a bit more concrete. Let's imagine we're building our own little app, a custom vacation planner. This simple app is going to be our guide as we explore the 4 pillars that really make all of modern software possible. All right, let's kick things off with our very first pillar. This one is all about security and control. The best way to think about it is like creating a safe, sealed capsule for our code. So in our vacation app, we have this thing called a travel package. And inside, it holds really important info, like the price. Now, you definitely don't want some other random part of the program to accidentally change that price to, 0, right? Of course not. This capsule makes sure that the data and the rules that manage it are all bundled together, nice and safe from the outside world. So, this whole sealed capsule idea, well, it's got an official name, encapsulation. It's the formal term for hiding the really important stuff and then creating very specific controlled ways for other bits of code to interact with it. You don't just leave the keys to the kingdom lying around. So why bother with all this? Well, it's all about building smarter, safer code. It means we can protect our data by setting up rules. For example, we can build a little check that makes sure the price of a travel package can never be a negative number. That kind of protection makes our code way more robust and so much easier to work with down the road.
And here's what that looks like in actual code. See that word private? That's the lock on our data capsule. It makes the price totally inaccessible from the outside. But then you see the word public? That's our carefully controlled key. It's a safe gateway that lets us check if a new value is okay before we ever let the price get changed. Pretty smart, huh?
Okay, so our package is secure, that's great, but our app needs different types of packages, right? What if we want to create a specific hotel package? We definitely don't want to write all that code from scratch again, so how can we reuse our original design? This brings us right to pillar number 2.
Instead of starting over, we can just have our new hotel package inherit all the basic features from the travel package. It works just like a family tree. The child, that's our hotel package, automatically gets all the traits of its parent, the travel package. Then it's free to add its own unique stuff, like, say, the number of nights you're staying.
And this principle is called inheritance. It's all about creating that parent-child relationship to achieve one of the biggest goals in programming, code reusability. I mean, why build something twice when you can just inherit it? It's all about working smarter, not harder.
And would you believe the code for this is actually super simple? See that little colon right there? That single character is what creates the whole family link between the hotel package and the travel package. Then you have the base keyword. You can think of this as the child respectfully checking in with its parent, making sure all the parent's setup code runs first before it adds its own details. It's incredibly efficient.
Okay, so our code is secure and it's reusable, but it also needs to be flexible. What if we want a single action, like book this trip, to act differently depending on what we're booking? I mean, booking a flight isn't the same as booking a hotel, right? This is where our 3rd pillar, the shapeshifter, comes into play. This really powerful idea is called polymorphism. It's a big word that literally means one name, many forms. It's the magic that lets a single command or a single function name do different things depending on the situation. It's what makes our code adaptable and, well, kind of intelligent.
Now, polymorphism comes in 2 main flavors. First up, you've got overloading. This is just having methods with the exact same name, but different inputs or parameters. The code is smart enough to know which one you want to use based on the data you give it. Then, on the other side, you've got overriding. This is where a child class in our family tree provides its own special version of a parent's method. The cool part? The program decides which version to use while it's actually running. Let's start with overloading. Check this out. Our booking system has a reserve method, but you'll notice there are 2 of them. One just needs a hotel name. The other one needs the name and the number of nights. It's the same action, reserve, but it has multiple forms to give us more flexibility. Now for overriding. Here we have a general travel service with a book method. That virtual keyword is like a permission slip from the parent. It's saying, hey kids, you can create your own version of this if you want to. Then, the child hotel service uses the override keyword to say, thanks, I'm going to provide my own special way of booking. So it's one name, book, but a totally different specialized action. All right, we've made it to the final pillar. Our code is secure, it's reusable, and it's flexible. But what about the actual person using our app? They don't want to see all this complicated stuff going on under the hood. They just want it to be simple.
I mean, think about driving a car. You use a steering wheel, a gas pedal, and a brake. You don't need to be a mechanic and understand the internal combustion engine to get where you're going. It's the exact same idea in software. The user of our vacation app just needs one big, friendly Book My Trip button. All the complicated logic that connects to hotels and airlines and payment systems, that should all be hidden away. That right there is abstraction.
An official term, abstraction, is all about taming complexity by hiding the unnecessary details. It's about presenting a simplified view to the outside world, whether that's another programmer or the person clicking the button, showing them only what they need to see to get the job done.
And we have two main tools for this. First is an abstract class. Think of it like a partial blueprint. It can provide some pre-built parts, but it can also define certain things that its children must build for themselves. An interface, on the other hand, is more like a strict contract. It provides zero implementation. It's just a list of rules saying, if you want to play my game, you must be able to do these things. Here's how an abstract class works in our app. By marking our travel package as abstract and giving it an abstract book method, we're creating a rule. We aren't saying how to book it, we're just enforcing a rule that says any future package inheriting from this one must provide its own book method. It's our way of guaranteeing that essential functions are never, ever forgotten.
So, let's do a quick recap of the blueprint. We started with encapsulation, our protective capsule. Then we used inheritance, the family tree, to reuse our code. We made it flexible with polymorphism, the shapeshifter. And finally, we simplified everything with abstraction, the simple view.
And here's the most important thing to remember. These pillars don't exist in a vacuum. They are a system. They all work together to let developers build apps that are secure by design, efficient to build, flexible enough to change over time, and simple enough to manage, even when they get crazy complex.
These 4 pillars are, without a doubt, the foundation of almost every piece of modern software you touch. They are the core ideas that turn a simple thought into a robust, scalable reality. So now that you know the blueprint, what would you build?